if you want to take a vacation, take it before that date, because who knows what will happen.
At this very moment, something extraordinary is unfolding behind our sun. The interstellar object known as Atlas, only the third visitor ever detected from beyond our solar system, is currently in solar conjunction, meaning it is completely hidden from our telescopes. 5 days ago, on October 21st, Atlas positioned itself on the exact opposite side of the Sun relative to Earth, rendering it invisible to our entire observation network. In exactly 3 days, on October 29th, it will reach perihelion, the closest point to our star in its long journey. During this period, an astonishing 33 gigawatts of solar radiation will bombard its surface. To put that into perspective, that's roughly 1/3 of the total energy output of all nuclear reactors in the United States combined, concentrated on a single object located 135 astronomical units from the Sun. This marks the most energetic moment of its million-year voyage through interstellar space. What makes this event especially fascinating is the timing. If any unusual physical processes were to occur, such as massive ice sublimation, the activation of complex chemical reactions, or something far more extraordinary, it would happen right now, precisely when we are unable to observe it. This raises profound questions. Why is this specific object, already known for its documented anomalies, passing through its point of maximum solar energy during the only window in which we are completely blind? Is it merely a statistical coincidence, or could there be something deeper and more fundamental occurring? Harvard professor and former chair of astronomy Avi Loeb has been sounding the alarm, stating, if you want to take a vacation, take it before October 29th, because who knows what will happen. These words are no longer distant speculation but a warning concerning the events of the next few days and the unknown processes that may already be taking place. Atlas has consistently defied scientific expectations for interstellar objects. Since its discovery, it has exhibited a series of anomalies that, while individually explainable, collectively form an unprecedented scientific puzzle. The first anomaly is its impossible orbital alignment. Atlas's trajectory lies within just 5 degrees of the ecliptic plane, the disk where all planets orbit. For an interstellar object, the probability of this alignment happening by chance is only 0.2%. However, this is not merely a statistical oddity, it is also the ideal trajectory for exploring our solar system. If someone were designing a mission to visit Mars, Venus, Earth, and Jupiter in a single pass, they would choose this exact path, as it allows multiple planetary flybys with minimal energy expenditure and course correction. The second anomaly involves its impossible chemistry. Spectroscopic data from the Keck 2 telescope revealed that Atlas emits nickel in proportions never observed in natural comets. On Earth, this specific signature only appears in highly controlled industrial processes, particularly in alloy production through the carbonyl process. Furthermore, the nickel is concentrated in a 600-kilometer region of the nucleus, while cyanide, another detected compound, extends to 840 kilometers. If both were naturally sublimating from ice, their behavior should follow similar patterns relative to solar heating and volatility, but they don't. The nickel appears as though it is part of an organized structure rather than random sublimation from a typical dirty snowball. The third anomaly is found in its revolutionary composition. Atlas contains only 4% water by mass, which is astonishingly low for a comet. Normally, comets are dominated by water ice. For instance, Borisov, the previous confirmed interstellar comet, displayed a typical aqueous composition. Atlas, on the other hand, is fundamentally different. Moreover, the polarization of light reflected from its surface is extremely negative, a phenomenon never before observed in known comets, including Borisov. This indicates the presence of unique surface or structural properties. The fourth anomaly concerns its extraordinary mass and scale. Atlas is estimated to weigh about 33 billion tons, making it 1,000 times more massive than Borisov and 1,000,000 times larger than Oumuamua. With a minimum diameter of 5 kilometers, it has enough mass to carry substantial payloads across interstellar space. To put this into perspective, it could theoretically transport thousands of small probes or hundreds of larger structures and still retain maneuverability using the energy available at perihelion. The fifth anomaly is its mysterious anti-tail. Between July and August, Atlas developed a stream of material ejected toward the Sun, opposite to the direction of its normal tail. Contrary to expectations, this was not a visual illusion caused by perspective. The material was genuinely being expelled against solar radiation pressure, implying the existence of active internal energetic processes. Dr. Loeb developed an evaluation scale ranging from 0 to 10 for assessing potentially artificial interstellar objects. On this scale, Atlas scores a 4, not conclusive, but significant enough to warrant serious investigation using planetary defense resources. The response from scientific and defense institutions has been both unprecedented and somewhat alarming. For the first time in history, planetary defense protocols, normally reserved for potential extinction-level threats, have been activated for an object that poses no direct impact risk. The Planetary Defense Network and the International Asteroid Warning Network, IAWN, which exists solely to detect and track civilization-threatening objects, initiated an intensive 3-month monitoring campaign for Atlas. This began on October 27, 2 days before perihelion, and will continue until January 2026. The decision to treat Atlas as a potential threat was made before perihelion, based on its unusual pre-existing data and anomalies. Yet, paradoxically, Atlas is not on a collision course. Its closest approach to Earth will still be 1.8 astronomical units farther than Mars. There is no conceivable impact scenario. So, why activate defense protocols? Adding to the mystery is NASA's silence. The Mars Reconnaissance Orbiter captured the highest resolution images of Atlas on October 3, when it was approximately 190 million kilometers from Mars. The high-rise camera, capable of achieving 30 kilometers per pixel resolution at that distance, 3 times sharper than the Hubble Space Telescope, produced the most detailed photographs of the object ever taken. Yet, these images remain unreleased. Avi Loeb has publicly requested access multiple times through blog posts and direct correspondence with NASA, but has received no response. The silence is striking, especially given the scientific significance of the data. In contrast, the European Space Agency, ESA, has shown more transparency. The ExoMars Trace Gas Orbiter captured images of Atlas that depict it as a classic comet-like object, a diffuse point with a small tail. At first glance, this seems reassuring. However, the spectroscopic analysis of the same data reveals anomalous chemical properties, reinforcing the notion that Atlas may not be a typical natural body. Physically, there are several possible explanations for Atlas's unusual behavior, each carrying profound implications for our understanding of interstellar matter and cosmic processes. Scenario 1: Exotic Natural Comet.